Hello, and welcome to yet another just thrilling and chilling video about Algebra 2. And this is Section 8, and this is quadratic functions in factored form. And what we want to do today is we want to be able to give you guys some tools on how to graph a quadratic function given in factored form. We identify key features of the graph. So the first thing I want to talk about is when you are in factored form, we can easily find the x-intercepts. So we can calculate, and let's think of a few things that we need. We need the x-intercepts, okay? Okay, we need the y or the y-intercept, okay? And then we need the vertex. Okay, and so, what we use here for x-intercepts, we use the factored form. For the y-intercepts, we plug in 0 for x. Plug in 0 for x. And then for the vertex, we do the x equals opposite b over 2a thing, and then the y value is equal to the function evaluated at that vertex point. Okay, so a little bit of algebra here, but nothing too crazy. So the first thing I want to do is just kind of look at this. And, when we have a function that's in factored form, when we have two things being multiplied, two binomials being multiplied by each other, what I want to do is I want to set, x minus 2 equal to 0. Okay, and I want to set x plus 4 equal to 0. All right. And so what I do then is, I just, solve for x. I'm just going to add 2 to both sides, so I get x equals 2. I'm going to subtract 4 from both sides here, and so I get x is equal to negative 4. So as a result, that's where these points are, okay? And I can plot those on the graph. I know where those are at, okay? And that's for the x-intercepts, okay? So the x-intercepts, okay? Intercepts. Okay, the next thing I want to do is find the y-intercepts, okay? And so when I find the y-intercept, that's when I let x equal 0 and solve for y, okay? And so basically what I want to do is just find f of 0 here and plug in 0 into our function. So I would do 0 minus 2 times 0 plus 4. And so as a result, when I calculate that, I'm going to get negative 2 and then positive 4, and that's going to give me negative 8. So I have this thing here where I say f of 0 is equal to negative 8. That translates to a point on the graph. Remember that is the point 0, negative 8. And that point is located right here. Okay? And then the next thing I want to do is calculate the vertex. Okay? So the vertex here. And let me copy down my function again, x minus 2, x plus 4. So f of x is equal to x minus 2 times x plus 4. And what I'm going to do here is I'm going to put this back into standard form. This is in factored form right now. So I'm going to FOIL this all out. So I'm going to do x times x, which gives me x squared. Okay, do the outside, so that's going to be positive 4x. The inside, so that's negative 2x. And then the last, which would be negative 2 times 4, which would be minus 8. Okay, so then I'm going to combine my like terms here in the middle. So I get x squared plus 2x minus 8. Okay, and this is my function. Okay, remember, guys, that these are the same thing. Okay, they're just written differently. And so for my vertex, what I want to do is I want to do, find the x value. X is equal to opposite b over 2a. Okay, and so my, if I just write down my a values, a is 1, b is 2, and c is negative 8, okay, then what I'm going to do here is I'm going to plug those values in. So I'm going to get opposite 2 over 2 times 1, and that's going to give me the value negative 2 over 2, which gives me negative 1. So I know that my, my vertex has an x value of negative 1, okay? That's the x value of my vertex. But what I want to do is I want to then plug that value back into my function and evaluate it to get the y value. So then I want to find f of negative 1, okay, which is going to give me negative 1 squared plus 2 times negative 1 and then minus 8. And so that's going to give me negative 1 squared is just going to give me positive 1. And then minus 2 minus 8. All right. Now, if I do 1 minus 2, that's going to give me negative 1 minus 8, and so this is just going to give me negative 9, okay? So I get the value of negative 9. So I have an x value of negative 1. I have a y value of negative 9. That gives me the point, negative 1, negative 9, and that's it, okay? And so then I can plot that point here, all right? And if I know that that's my vertex, you know, I have these 4 points, and I just draw a parabola that connects all of them. So that's the idea. Let's go to the next page. This is fun. I'm having a good time. All right, so, you know, what we have here is, you know, we want to determine the x-intercepts to graph a quadratic function. Find the midpoint between the x-intercepts and the x-axis. Okay. Evaluate the function to find the vertex. That is the vertex. Okay. And then find the y-intercept and then graph the points as necessary. So we have these two graphs here. Okay. And this is going to give us this is in standard form. This is in factored form. So first thing I want to do, let's calculate the x-intercepts. So I'm going to copy down my function again up here. I'm going to call that f of x is equal to x plus 1 times x plus 7, okay? And I'm going to set each of these binomials equal to 0, okay? And x plus 7 equals 0, all right? So if I subtract 1 from both sides, I'm going to get that x is equal to negative 1, and then subtract 7 from both sides, and I get that x is equal to negative 7, okay? These values here are my x-intercepts, okay? And so now I'm going to take those, I'm going to plot those on the graph at negative 1 and negative 7, okay? And I'm just going to put those points here, negative 7 and negative 1, okay? That's where those points go. Okay, now what I want to do, let's calculate the vertex. All right, so let me do that. Let me do the vertex here. And I want to use the standard form. So I'm going to do f of x is equal to x squared plus 8x plus 7, okay? And what I want to do to find the vertex, I want to use x equals opposite b over 2a, all right? So then I know from the standard form version, I know that a is equal to 1, b is equal to 8, and c is equal to 7. So I'm going to do opposite b, so x is going to equal negative 8 over 2 times a, which is 1, and that's going to give me negative 8 over 2, which gives me negative 4, okay? So the x value of my vertex is going to be x equals negative 4. Now what I want to do with that is I want to plug that value into my equation, or my function, to find the y value. So if I do f of negative 4, okay, then that's going to give me negative 4 quantity squared plus 8 times negative 4 plus 7. All right, so then this is negative 4 squared is going to give me 16, and then minus 32, and then plus 7. Now 16 minus 32, that's just going to give me negative 16 plus 7. So negative 16 plus 7, that's going to give me, what is that, negative 9? Okay, so I have the y value. Okay, so f of negative 4 equals negative 9. This translates to the point negative 4 comma negative 9. Okay, and this is my vertex. Okay, so if I take that point and graph it over here, so negative 4, negative 9, and this was, hold on, we gotta, okay, so this is negative 2, negative 4, negative 6, negative 8. Negative 9 is right here, so negative 4 is over here, so let's graph that point right here. That's my vertex. And that's really, you know, all we need. Let's find the y-intercept. Okay, so if I find the y-intercept, do that work here, then I'm going to find f of 0. Okay, so I'm going to do 0 squared plus 8 times 0 and then plus 7. Okay, and what you kind of find out whenever you do this, whenever your value's in standard form, this last term, your c value, is your y-intercept. Okay, and the reason why is because you know, 0 squared is 0, 8 times 0 is 0. You're just left with 7. So you get the point f of 0 is equal to 7, which gives you the x value of 0, the y value of 7. So now I'm going to go back up here and plot that point, which would be up over here. Okay? And then what we want to do is we want to just take those points and connect them with a parabola. Parabolas, computers, we're having fun. We're having a great time. All right? And that's how we graph, okay? As long as you have some points on there and you know what it's supposed to look like, then that's what we're going to get, okay? A lot of fun. We're having a good time. Okay, what I want to do is we want to plot the function. Let's do this again. We have the equation y equals the quantity x plus 1 times the quantity x minus 3. So the first thing I want to do is find my x-intercepts. So I'm going to come here, and I'm going to zoom way in, and I'm going to rewrite this. Y equals, x plus 1, x minus 3. So x plus 1 times x minus 3. Okay, so for my x-intercepts, I'm going to do that here, x-intercepts. Okay, remember, I'm going to set x plus 1 equal to 0. And I'm going to set x minus 3 equal to 0, okay? Subtract 1 from both sides, so then I get that x is equal to negative 1. Okay, add 3 to both sides, and so that's going to give me that x is equal to 3. Okay, so at those points, okay, I know I have the point negative 1 and then 0, okay? And then I have the point 3, 0, okay? And I'm going to plot those points on the graph. So negative 1, 0, and then 3, 0. So here's negative 1, 0, and here's 3, 0, okay? Now what I'm going to do is let's find the vertex, okay? The first thing I need to do, I'm going to rewrite my function y equals x plus 1 times x minus 3, and I'm going to multiply this out, and so I get y equals x squared minus 3x, and then plus an x, and then minus 3. All right, so what I end up doing is I want to combine my like terms. So I get x squared. Negative 3x plus an x gives me negative 2x. So minus 2x and then minus 3, sorry. Okay, so this is my equation in standard form. All right, so if I put that in standard form, then what I want to do is I want to identify my a value, which is 1, my b value, which is negative 2, and then my c value, which is negative 3. All right, so what I'm going to do is I'm going to do, x is equal to opposite b over 2a. And so opposite negative 2, okay, opposite negative 2 over 2 times 1. And that's just going to give me positive 2 over 2, which gives me 1. So I have x equals 1. That's the x value of my vertex. Now I plug that into my function. And so I'm going to get y of 1, plug that in. And so I'm going to get 1 squared minus 2 times 1. So minus 2 times 1. And then minus 3. So I get 1 minus 2 minus 3, which is going to give me, what is that going to give me? Negative 6? No. So 1 minus 2 gives me negative 1, minus 3 again gives me negative 4. Sorry. Okay. So now I have the x value of 1, the y value of negative 4, so I have the point for my vertex is going to give me the point 1 comma negative 4. All right. So that's another important point. So I've got 1 comma negative 4. Now if I come over here and graph that, all right, then what we find out, and let me put that here, 1 negative 4 is right here. Okay? And that's that. All right? The next thing I want to have is find my y-intercepts. Okay, so my y-intercepts. All right, and what I want to do is I have my equation y equals, negative 2x minus 3. So I've got y equals x squared minus 2x minus 3. So if I plug in 0 for x, okay, y equals 0 squared minus 2 times 0 and then minus 3, I'm just going to get the value of y equals negative 3. Okay, and the y-intercept translates to the point 0, comma, negative 3. All right, so I'm going to put that point here, 0, negative 3, and that's another point that's on the graph right here. Okay, let me actually color this black because that's where I found my vertex in. And this is my y-intercept. Okay, so now what I want to do is I just want to connect these points with a fun little line that we call a parabola. All right, and it doesn't have to be perfect, but you want to get the right idea. You want to at least have those points graphed. Okay, and hopefully yours doesn't look like as crappy as mine, which looks like a V. It should look like a parabola. Okay, all right. So the next thing I want to do is this. When we have something with double roots, where you have the same thing, okay, x plus 5 and then x plus 5. What we end up having, all right, is this, okay? If we were to find the x-intercept, okay, then I would set each of these factors equal to 0, okay? So I get this. So I get x plus 5 equals 0, and I get x plus 5 equal to 0. So I get two of these, okay? So if I subtract 5 from both sides, I'm going to get x is equal to negative 5. Do the same thing here, okay? And I get x is equal to negative 5. All right, so you get the same thing when you have double roots. All right, well, let's go ahead and let's look at our vertex, okay? Let's see what we get with the vertex. And let's go over here real quick, and let's just graph that point at negative 5. So here's negative 5. Okay, plot that point. We only have one of them, all right? So that's kind of weird. But my vertex, all right, what I want to do is I'm going to, if my function is f of x equals x plus 5 times x plus 5, then if I multiply this out, and I'm going to get x squared plus 5x plus 5x, and then plus 25, all right, I get x squared plus 10x plus 25. Okay, so in order to find my vertex, what I end up getting here is, if x is equal to opposite b over 2a, and let's do a is equal to 1, b is equal to 10, c is equal to 25. Okay, what we end up getting is that x is equal to opposite 10 over 2 times 1. So we end up getting the x value of negative 10 over 2, which gives us an x value of negative 5. So if x is equal to negative 5, all right, that's my x value of my vertex. Now if I plug in negative 5 into my function, if I do f of negative 5, all right, then that's going to give me negative 5 squared plus 10 times negative 5, and then plus 25. All right, and let's find that y value, and that's going to give me, this is 25 minus 50 plus 25. Okay, 25 plus 25 gives me 50 minus 50, which is going to be 0. So I get a y value of 0 here, so I get the point negative 5 comma 0. Wait a second. That's the same thing as my value here, okay? So that's the same value as my x-intercept. So my vertex is actually my x-intercept, all right? And if I wanted to find the y value, the y-intercept, okay, so the y-intercept, okay, if I have the function f of x is equal to x squared plus 10x plus 25, okay, if I plug in 0 into my function, I get 0 squared plus 10 times 0 plus 25, and that's just going to give me a value of 25. So I have the point 0, comma 25, all right? And that's what I'm just going to have up here. It's going to be way up here. So if you draw your parabola, just make it look like this, all right? And that's the idea, all right? So it's kind of an interesting problem, but, it is what it is, okay? So when you do have double roots, your x-intercept and your vertex are usually the same thing. Okay, now you're probably wondering, how did I know to graph this function and have the graph open up? And the reason why is because when I put it into standard form, when I had f of x is equal to, x squared plus 10x plus 25, my leading coefficient is positive, okay? My leading coefficient was positive, and so I knew that my graph opened up, okay? So the leading coefficient is positive, my graph opened up, all right? Over here, all right, on this one, if you factor out, if you multiply all this stuff out, okay, if f of x is equal to negative x plus 5 times x plus 5, all right, then you get this. It's basically like negative 1 multiplied by all this stuff. Now, we've already multiplied this out, and this gives us x squared plus 10x plus 25, okay? And when I multiply out that negative 1, I get negative x squared minus 10x minus 25. The reason why I'm doing that is because my leading coefficient my leading coefficient, the number that's in front of my x squared, is negative. And that means that my graph is going to open down. Okay, and that's how you can kind of tell. All right, so it's important that we know how to do that, and we can look at these quadratics and know what they're about to do. Okay, and all that does is just flip it down, go the other way. So I hope you enjoyed this video, and we'll see you in a bit. Thanks. Bye.